Right, girls, this is question 3 from the exam paper in 2017. It's on the rates of reaction, which is chapter 16, and it's on the experiment there, which we affectionately call disappearing X, because basically you have the sodium thiosulfate solution and the hydrochloric acid, and together they make this sulfur precipitate, which causes the X at the bottom of the flask to disappear because you can't see through the sulfur as it gets thicker. So I'm just going to have a look at this question. Part A there is just a definition, define rate of reaction. Lots of information about the experiment then. They've given you some of the data here, and then they've asked you these questions. So part B there, describe a method that you could use to determine when the same mass of sulfur had been formed in each run. So that's just looking at the disappearing X again at the point. One thing that you could do is you could look at the point at which the X disappears, and at that point that gives you an indication that the same amount of sulfur is present, the same concentration of sulfur is produced at that point. So that's the method. So, and then in part C, we're doing a calculation, and in part D, we're looking at a calculation there as well. Part E, just again, describe how you could use the same reaction to investigate the effect of changing temperature on the rate of reaction. So what you'd be doing there is instead of changing the concentration or the volume staying the same, the concentration, instead of changing this, you'd be changing the temperature each time. You'd be keeping the concentration the same each time. So that's how you do the last part. But I'll focus there on part C and part D. C, because they're the two mathsy parts, and they're the two parts that need to be explained. So if you like, you can, pause the video, you can have a look at part C, copy column X into your answer book and fill in the missing concentration. So this is column X. So I'll show you how we do that. So I'll just move this over here. You can still hopefully see column X there. So if we're doing part C from 2017, question 3, we're copying X into our answer book. So they're saying that we've got 30, and then there's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 0 down here. Now, what you can see is that this is 100%. There's no water for dilution. It's 100% of the stock solution. So that's why it ends up being 30. Then as you go down, it becomes more diluted. So what I'm going to do is I'm going to work out the factor by which it is diluted. So what I'm going to do is, in number 1, if we label these 1, 2, 3, 4, 5, 6, just like the run there. And if we have a look in number 1, we have 100 out of 100 is the solution, which is 1. And if we multiply the 1 by 30, we get 30 because it's not diluted. If we look at number 2, it's only 80 of the 100. 80 over the 100, that is the stock solution. So that's 0.8. And if we multiply that by 30, we'll get the concentration of it. In number 3, it's 60 over 100. In number 4, it's 40 over 100. In number 5, it's 20 over 100. And then in number 6, it's 0 over 100, which gives us 0. Multiply by 30 will give us 0. And that's where we get this from. So this is 0.6. This is 0.4. This is equal to 0.2. And if you multiply each one of these by 30, we'll get the concentration in that particular run. So if we say 30 multiplied by 0.8, we get 24. If we get 30 multiply by 0.6, we get 18. If we get 30 multiply by 0.4, we get 12. And if we get 30 multiply by 0.2, we get 6. So this is column X here. This one here. Just like that. So that completes part C. If we look at part D then, part D is another calculation. Copy column Y into your answer book and fill in the missing rates correct to 3 decimal places. So this is column Y, and you can see that Y is or the rate in seconds to the -1. So you've been given time in seconds. So if you need to work out the rate or in s to the -1, what you need to do, I suppose the clue is here, that if this is in seconds and this is in seconds to the -1, you need to put 1 over the time. So what I'm going to do is I'm going to write down, again I'll write down runs 1 to 6. Just see if you can move this down a little bit and you can still see it. So if we go 1, 2, 3, 4, 5, 6, and if we write down the time for each one of these, which is 50, 63, 83, 125, 250. Okay. And then if we put 1 over each one of these, and give yourself a column to do it if you like, 1 over 50, 1 over 63, 1 over 83, 1 over 125, 1 over 250, and that's where we end up with nothing really there, because it never really ends. So that's why they've ended up giving this a 0. So then using a calculator, 1 divided by 50. The question also tells us to put it into correct 3 decimal places. So when we work this out, we get 0.02. If we put 1 over 63, we get 0.016. Then if we get 1 over 83, we get 0.012. If we put 1 divided by 125, we get 0.008. And if we get 1 divided by 250, you get 0.004. And that's all of the values there now corrected 3 decimal places. You'll see that I put in a 0 there just to make that 3 decimal places as well. They could take a mark off you, even though it is a 0, but they have asked you to be 3 decimal places, so you might as well give them 3 decimal places. And you know, if you're being really pedantic, you might as well give that, you know, 3 decimal places as well if you want to be very careful. So that's D part 1. This is column Y. Just like that. The part 2 of this is, it says, move it back into shot there. Plot a graph of concentration of sodium thiosulfate in grams per liter. Okay, concentration of sodium thiosulfate in grams per liter. That's your column X. Versus rate, or that's column Y, for runs 1 to 6. So that's the next thing that we'll do. So just planning out what how I'm going to draw this. You can see that there is, if we're starting down here in this corner, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes up. And we've got 1, 2, 3, 4, 5, 6, 7, 8 kind of boxes across. So what I might do is I might draw my axis. I think I'm going to go up in threes. Because that would get us up to 30. So if we make this point down here 0, and if we're going up in threes, we'll make it to 30. So we'll go 3, 6, 9, 12, 15, 18, 21, 24, 27, and then 30. Okay, so that's column X. Column X was the concentration of Na2SO3 in grams per liter. Okay, and then along the bottom we're going to go with column Y, which is R in S to the minus 1. So this is column Y. If you see here, we're going up in fours. It's pretty steady, going from 0, 4, 8, 12, 16, 20. So if we went up in fours, we'd go across 5 boxes. That would be 1, 2, 3, 4, 5. So if we made this 0.004, 0.008, 0.012, 0.016, 0.020. Okay, it's always important to use as much of the page as you possibly can. You know, you can sometimes put in an extra one just to show that you've make it look like you've made use of a little bit more of the page, but definitely try to go more than half of the page anyway. So if we're looking at run 1, okay, run 1 is looking at the idea that we have 0.02, which is this one here, and 30. That's our point there. If we're looking at run 2, we've got 24 and 0.16. So that's that one, that one, that one, that one. Then run 3, looking at 18 and 0.12, 18 and 0.12. Then the next one is 12 and 0.008, which is this one here. The next one, 6 and 4, 6 and 4, just this one here. And the last one is 0 and 0. Nice to tick them off as you go. We're going to draw the point between those points, draw the line between those points. You'll see that it's a straight line, which is exactly as you would have seen in the theory. Perfectly fine to use a ruler to draw this one. You can see there that we end up with our straight line through the origin graph, and quite a lot of marks for that. So there'd be marks for labeling the axis correctly and plotting the points correctly, and then drawing the line. Okay, what you can give it a title of concentration of sodium thiosulfate in grams per liter versus rate in seconds to the minus 1 if you like. Okay, but this is the main part of the information that you require. The last part of the question, the last part of this part D, this is D part 2, is looking at what can you conclude from the graph. Okay, and obviously what you can conclude is that it's a straight line through the origin. Okay, and a straight line through the origin means that the concentration is directly proportional to the rate. So if it's a straight line through the origin, it's directly proportional are kind of the key words that you need to mention. The concentration is directly proportional to the rate.